Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Good evening, ladies and gentlemen. My name is Muhammad. So today we'll be talking about electricity, physics, electricity and magnetism. And the topic we'll be talking about now is Coulomb's law. So many people used to call it Coulomb's law, but the name is not an English name. So it's not Coulomb's, it's called Coulomb's. So it was found by a scientist called Charles Austin de Coulomb's. So Coulomb's law states that the force of attraction or repulsion between two point charges, this point must be there, please take note, between 2 point charges is directly proportional to the product of the charge and inversely proportional to the square of the distance between them. So now, please, why did I say this point must be there? This point is very important because Coulomb's law only works for point charges. If a charge is not a point charge, then it is not accepted. And what we mean by point charge is a charge that is very, very small, a charge with very, very small value. So that's what we refer to as point charge. When the charge is not small, then Coulomb's law won't work. Coulomb's law only works for point charges. So what is the law saying? The law is saying force is directly proportional to the product of the charges, to the product of the charges, and inversely proportional to the square of their mean distance. So F here stands for the force, Q1 and Q2 stands for the charges, and R stands for the distance. So anytime there is proportionality, whenever you remove proportionality, you must have a constant. So now that is why we have F is equals to the constant we have, because we change this proportionality to an equal sign, so we'll introduce a constant called K. So now this K is our constant, and this is our Q1, Q2 over R square. Mind you, so this constant K is given by 1 over 4 pi epsilon naught when it is in an empty space. So it was calculated to be equals to 9.0 approximately times 10 raised to power 9 Newton meter square per Coulomb square. So now, example, let's take an example and look at it well. They say 2 point charges of magnitude plus 2 microcoulomb and minus 3 microcoulomb are separated 5 centimeter apart. Calculate the type of force and the nature of the force. Now, we have two charges here, right? Plus 2 microcoulomb and minus 3 microcoulomb. And they are separated by what? A distance of 5 centimeters. That's why I brought out the distance here. So what we are supposed to know here is that here there is positive and here there is negative. In calculation of force, there is none of your business with the positive sign or the negative sign. You just calculate your thing direct. I hope you are getting it. When you are calculating force, you don't deal with the sign. You forget about the sign. The sign is only telling you the nature of the force, which you will see in a moment. Now, Q1 is 2 microcoulomb. Micro here stands for 10 raised to power minus 6. That is a symbol for 10 raised to power minus 6. So if we change it from microcoulomb to coulomb, it will be 2 times 10 raised to power minus 6 coulomb. Now here 3 microcoulomb. Micro is 10 raised to power minus 6. So it will be 3 times 10 raised to power minus 6 coulomb. Now R is always measured in meter. Therefore, we have to convert this centimeter to meter. This centi here is also 10 raised to power minus 2. So it will be 5 times 10 raised to power minus 2 meter. So and our constant K is 9.0 times 10 raised to power 9 Newton meter square per Coulomb square. Per Coulomb square. So now F is equals to K Q1 Q2 over R square. What is our K? 9.0 times 10 raised to power 9 Newton meter square per Coulomb square, multiplied by our Q1 is 2 times 10 raised to power minus 6. Our Q2 is 3 times 10 raised to power minus 6. Now, these 2 coulombs here will cancel this per Coulomb square. then this meter square here will cancel this meter here. So 9 times 2 times 3 will give us what? 54. Now 5 square is 25. 54 divided by 25 will give us 22.16 times. Now 9 minus 6 will give you 3. 3 minus 6 will give you minus 3. Minus 3 minus 4 will give us minus 3 plus 4, which is 1. So if you multiply 2.16 times 10 will give you 21.6. So forget about my mathematical manipulation. You can press your own calculator to testify the answer. But this is not where the question stops. This question says, and the nature of the force. The nature of the force. What is the nature of the force? Remember, we said when dealing with an electric field, one thing we must put at the back of our mind is that what? Like charges repel, unlike charges attract. So look at this, positive and negative. So they are unlike charges, therefore they will always what? Attract. So this will be attractive. So it will be 2.146 Newton. Attractive. So that is the answer. Attractive force. The force is the nature of the force is an attractive force. Now let's look at example 2. They say the force between two equal charges are 40 Newton, and when the distance is, that is when the distance is 2 centimeters, what will be the force when the distance is increased to 5 centimeters? Now you are given the first force, you are given radius, you are asked to find second force, you are given second radius. Now look at it. In Coulomb's law, there is no relation like this. But recall that they say force is inversely proportional to the square of the distance. If I remove this proportionality, it will introduce a constant, meaning F is equals to K over R square, right? Now, by cross multiplying, you have F R square is equals to K. And what is K? K is constant, meaning FR square is equals to constant. Remember from Boyle's law, we say PV is equals to constant, cool? And then see anything that is equals to constant, we will say P1 V1 equals to P2 V2. So the same thing is happening here. Anything that is equals to constant, meaning 1 must be equal to 2. So therefore here, since FR square is equals to constant, that means F1 R1 square is equals to what? F2 R2 square. Now let's substitute our data. What is our F1? 40 Newton. What is our R1? 2 centimeter. What is our F2? Unknown. What is our R2? 5 centimeter. Now all squared. So now 2 squared will give us what? 4 centimeter squared. And here 5 square is what? 25 centimeter square. So now this centimeter square here will cancel this centimeter square here. What are we left with? We are left with Newton. Now F2 will be equals to what? 40 times 4, which is 160 Newton. Now is equals to what? 25 F2. So now we divide both sides by 25 to get our F2. 25 go with 25. 160 divided by 25 will give us 6.4 Newton. So this is your second force. Now let's talk about the third example. The third example says the force between two charges are separated by a distance of r is 10 Newton. Calculate the force when the distance is half. Now also they talk about force and distance, and we have already derived at the back that whenever we are given force and distance, we should also always say F1 R1 square is equals to F2 R2 square. Now our F1 is 10 Newton. Our first distance, they say at a distance r, so it will be R1 is equals to r. Then our F2 is what we are looking for. Our R2, they say the distance is half, so it will be half of r. So now from here, substituting into F1 R1 square equal to F2 R2 square, our F1 is 10 times our R1, which is r. R1 is r squared. Now F2 is equal to F2, we don't know. Then R2 is 1 over 2r, so we put it 1 over 2r all squared. Please don't say 1 over 2r squared, no. All this 1 over 2 is together with the r, so you put it in the bracket and square it. So now this will now give us what? 10 times r square will give us 10r square. Now r square will give us r square, 2 square will give us 4. So it will be F2 r square over 4. So now this r square will cancel this r square. What do we have remaining? F2 over 4 is equal to 10. We have F2 over 4 is equal to 10. Now by cross multiplying, you have F2 is equal to 10 times 4. So now F2 will be equals to what? 10 times 4, which is 40 Newton. So this is where we are going to stop for today. Inshallah, in our next class, we will solve more examples and move to next topic. Once again, I'm Sam Muhammad. Assalamu alaikum wa rahmatullahi wa barakatuh.